Hey everyone! We are going to start a vodcast here in IC for this particular homework assignment. This homework assignment is for the synthesis, decomposition, and combustion reactions. So if you're checking out the class website, this is on the very bottom of Unit 6. This is the worksheet that you need to start first. The other worksheet that you guys have is kind of like secondary compared to this one. The other one that I also have posted on the class website is the net ionic equations. And that worksheet is not going to be due next class, so you got to prioritize. Let's do this one first. I started a few problems in class, but let's go ahead and show you a few that I did not show you. Alright, up at the top, we got this one. So we're going to start with the synthesis and just kind of work our way down, okay? Alright, it's problem number 1 at the very top. Sorry, my phone's about to die, so I plugged it in. Okay, let me close this out. Okay. Alright, so in order to make this a little bit better for you guys, I do have my solubility rules and my cation and anion sheet and all that stuff. That'll kind of help you out, okay? You're going to want to have that available. Alright, so all you have to do is predict what your products are and then balance the reaction if necessary. So starting right off the bat, we already gave you your reactants, and then on the product side you need to figure out what sulfurous acid is. So there's some rules for naming acids, and when you have an us at the end of the name of the acid, that comes from an ite ion. So on the cation and anion sheet you would look for sulfite. Okay, so come back over here. Sulfite is right here at the very, very bottom. The formula is SO3, and it has a charge of -2. Okay, so here we go. In order to change this into an acid, you want to put some hydrogen ions in the front. And you just need to remember that the charge of a hydrogen ion is +1. So to get the formula, H2SO3. Alright, so that's your product. The two reactants that you had were SO2 and water. Alright, the last thing that you have to do is just kind of check for any gases. That's kind of the point. If you look at the instructions on this guy, and go back. It says, in this reaction, two different molecules or atoms unite to form one. First, write the correct formula on the right-hand side of the arrow. When the substance is a gas, indicate this by writing a G, and then balance the equation. So really all I want you guys to worry about in the top half are any gases that you might have. And on the cation and anion sheet, just kind of check this out, I just want to show you. SO2, which is one of your reactants. If you look over here where it says common inorganic gases, SO2 is listed there. He's a common inorganic gas. So I'm going to come back over here, and I'm going to label this guy as a G. And then for those of you who are curious, this is water. Water is a pure substance. It's a liquid. You don't have to mark these on your homework, but I'm just going to show you anyway. And then an acid is created. So basically what you do is you bubble in. Guys, you're too loud in the back. Too loud. So anyway, what you're going to do is you're going to bubble the gas into liquid water. And when you bubble that gas inside, it'll dissolve and create an acid that is dissolved in that water. So all you would have to do technically is just label that G, but I'm doing the whole thing for you just so you can see. And then final check, is it balanced? Because you do have to balance these reactions. And yes, this guy is already balanced. So this question number 1 is done. Alright. Question number 2. Alright, so the formulas have already started for you on the reactant side. On the product side, you made sulfur dioxide. So sulfur is a nonmetal, and that makes him covalent. So we do not have to worry about balancing charges. There's no prefix on the sulfur, but there's a prefix, a di, on the oxygen. Alright, so that's your product. This one's going to require some balancing. Alright, so there's the bare bones skeleton reaction, and you just want to start balancing this through. So we have 8 sulfurs there, but only 1 here, so I'm going to put in 8. It gave us 16 oxygens, so I'm going to have to put an 8 in front of this guy right here. And then you're done. Oh, almost forgot. This guy is a gas. S8, you could look him up on the internet. He's actually a solid. And then SO2, I don't know if you remember from the previous problem, but sulfur dioxide is also another gas. Now, just FYI, I'm just letting you know, S8 is actually a solid, so I'm going to go ahead and label that as an S. You can burn a solid chunk of sulfur. You can actually burn it, and it'll create sulfur dioxide gas, and that gas is really stinky. It's disgusting. You would not want to be hanging around sulfur dioxide. It's just a terrible smell. Also, I think it's toxic. I think sulfur dioxide is toxic. Okay, question number 3 I already did in the classroom, so I'm going to skip that one. Let's go to question number 4. Alright, already got some formulas. That'll save you a lot of time. Okay, we got to figure out who this is. Iron 2 chloride. Alright, iron is Fe, chloride is Cl. The iron has a +2 charge because of that Roman numeral. And now you just have to get the charge of your chloride ion. Okay, so chlorine is element 17. He's really close to element 18, a noble gas. So he's going to gain 1 electron. We want to balance these charges. Alright, so there's your product. Okay, so this is what your reaction looks like. And I kept this pretty easy for you. The only thing I need you guys to do is to go back and label your gases. So start checking your gases. This is a gas. And just FYI, this is solid. And you don't have to have this, but this is also a solid. Right, in the presence of chlorine gas, iron will actually rust right in front of your eyes, and it'll do it so fast. It looks like it's rusting, but it's actually forming this. It's forming iron 2 chloride. So, alright, let's keep going. Okay, question number 5 has a tiny little typo. Do you guys see that little number 6 right there? Whoopsies. Get rid of it. Okay, that was just a little tiny typo right there. Alright, here we go. Okay, same process as before. I started you off with some formulas. You're welcome. Copper to bromide. So this copper has a +2 because of the Roman numerals. And bromide, okay, he's Br. You have to check his location on the periodic table. He's just a -1. Okay, so got to balance this out. And you've already got this stuff over here. Okay, you got to find your gases. Don't forget to do that. Bromine is a nonmetal. That is also not a noble gas. And that's why we put a 2 on there. Okay, a lot of metals in the presence of these halogen gases react violently. Right, so this is a synthesis reaction. And copper bromide kind of looks like rust. It looks kind of weird. Okay, question number 6 is a really common question for my students. They're like, what the heck is ammonia? I got you. You could like totally Google that or something. Just saying, you could. What's the formula of ammonia? Be like, Siri, what's the formula of ammonia? And I'm pretty sure Siri would even know the answer. Alright, but anyway, ammonia, you could look it up. It's NH3. That's ammonia. Alright, so now that you know what your product is, got to balance this out. It's not even close. Here we go. Let's see, 2 nitrogens there, so I'm going to put a 2 right there. That'll give you 6 hydrogens, so I'm going to stick a 3 right there. Alright, you guys, gases. Nitrogen's a gas, hydrogen's a gas, and ammonia can be a gas if it's exothermic. So you can actually stick a gas right there as well if you want. Not necessary, though. Anyways, alright, so I think you guys are starting to get the hang of it. I'm not going to show you the last two on the vodcast. Just keep going as normal. I think you can handle that. Alright, so let's go into the middle. In the middle, I'm pretty sure I did question number 2 in class, so I'm going to do question number 1. Alright, this is the opposite problem from the first set. Okay, in the first set we were bringing stuff together, but in this one we're breaking them apart. These are decomposition. Alright, let's start with some formulas. Magnesium carbonate. Alright, Mg, magnesium, carbonate, I'll help you out. He's on the list though. You should always have this ready and available when you're working on these problems, okay? Carbonate is CO3 and it has a -2 charge. CO3 with a -2 charge. And this guy, you're going to have to predict his charge. He's +2. Alright, so magnesium carbonate is MgCO3. And you notice that you have an arrow, so this guy's decomposing. Let's see what he decomposed into. Magnesium oxide. So you still have magnesium, but now you've got oxide. Okay, oxide is O, and he's a monatomic ion. You see the "ide." He's not going to be on your list, and that's kind of a dead giveaway that he's on your periodic table. And he has a -2 charge. So when you bring these guys together, it's a perfect match. +2, -2. Next you'll see the word "and." That means that we have to separate it with a plus sign. Carbon dioxide. I think you guys know what that is. And I hope you know that carbon dioxide is a gas, so go ahead and label it as a gas. And then you would need to balance the entire reaction. And as you can see, it's already balanced. Pretty easy. Okay, I already did number 2 in class. Wow, number 3. That's a pretty big one, huh? Okay, if you borrowed an iPad today, now would be a good time to maybe put those away. Don't worry about plugging them in, but please close the cabinet behind you, okay? Alright, let's start off with potassium nitrate. Potassium is K, it's got a +1. Nitrate is NO3, and he's a -1. So that's the correct formula. Looks like we got an arrow, so this guy's decomposing. Let's check him out. Potassium oxide. Potassium again. Oxide is oxygen, and this guy's got a -2 charge, so you're going to have to balance that out. Okay, nitrogen monoxide is actually a gas. Alright, let me label him. He's actually on your list too of some of the common gases. And then oxygen can't stand alone. He needs to be oxygen gas. So we typically label him as O2. Alright. So obviously since it's towards the end of class, I kind of need to go help people clean up. So I'm going to stop the podcast here. I hope that did help you out though. Catch you later.